A hearty welcome to today's chemistry session. Today we will have the session Laws of Chemical Combinations and Dalton's Atomic Theory. The compounds are formed by the combination of different elements. This combination of elements to form compounds is governed by 5 basic laws. Let's see those laws in detail. So let's start with law of conservation of mass. This law is quite familiar to you, and this law was put forth by Antoine Lavoisier in 1789. He is also known as the father of modern chemistry. Law of conservation of mass states that during a chemical reaction, no matter is created or destroyed. It's just rearranged. You can see here 4 hydrogen atoms react with 2 oxygen atoms. You are getting 2 molecules of water. The reactants and products are quite different. Okay, but still the number of hydrogen atoms and the number of oxygen atoms involved in the chemical reaction as reactants is the same in the product side also. The number of the reactants, number of the atoms involved in that reaction remaining the same in the reactant side as well as in the product side. The chemical equation is balanced. So that is known as the law of conservation of mass. Now next, the law of definite proportions. This law was given by a French chemist, Joseph Proust. The law of definite proportions states that regardless of the amount, a compound is always composed of the same elements in the same proportion by mass. This you can understand by taking a simple example of water. If you take 1 liter of water or 2 liters of water or half a liter of water, whatever it may be, the compound water H2O will be always containing 2 hydrogen atoms and 1 oxygen atom. It won't change according to the weight or amount you take. That is, regardless of the amount, a compound is always composed of the same elements in the same proportion by mass. Next, the law of multiple proportions. When 2 elements combine with each other to form more than one compound, the mass of one element that combine with a fixed mass of the other are in a ratio of small whole numbers. Law of multiple proportions can be well explained by taking the example of carbon monoxide and carbon dioxide. Carbon combines with oxygen to form both carbon monoxide and carbon dioxide. In carbon monoxide, there is only 1 carbon and 1 oxygen. So the mass of carbon is 12.01 and the mass of oxygen is 16. In case of carbon dioxide, there is 1 carbon and 2 oxygen atoms. So the mass of carbon is 12.01, the same, and the mass of oxygen is 16 into 2, 32. Therefore, the ratio of oxygen in carbon dioxide to oxygen in carbon monoxide is 2:1. So that is example for the multiple proportions. The same element can be combined in different proportions to form different compounds. Now let's consider the next law, that is Gay-Lussac's law of combining volumes of gases or Gay-Lussac's law of gaseous volumes. This law states that when gases combine or are produced in a chemical reaction, they combine in simple whole number ratios. These simple whole number ratios we can easily identify by looking into a balanced chemical equation. So here we have an example, N2 plus 3H2 gives 2NH3, the formation of ammonia. Here the coefficients of the balanced equation will tell you the simple whole number ratios in which the gases have combined. Gay-Lussac's law of gaseous volumes can be explained by taking the example of formation of water. So, it is a reaction of hydrogen and oxygen gases. 2 volumes of hydrogen will combine with 1 volume of oxygen to produce 2 volumes of water. It is well understood by looking into the balanced chemical equation for the formation of water. 2H2 gas plus O2 gives 2H2O. So looking into the coefficients, you can identify hydrogen is 2 volume and oxygen is 1, and then the formed molecule, water molecule, is 2. So 2 volumes of hydrogen combined with 1 volume of oxygen to give 2 volumes of water. Next, let's consider Avogadro law. This law was put forward by Avogadro in 1811. He was an Italian chemist. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. You can see here hydrogen, oxygen and carbon dioxide, different gases. If it is taken in equal volumes at same temperature and pressure, these all will contain equal number of molecules regardless of its size of the molecule or anything. For example, it's 1 mole of any gas takes up a volume of 22.4 liter at STP. You don't know 1 mole, which you will be studying in detail in the coming sessions. 1 mole means 6.022 into 10 to the power of 23 atoms. This you will study in detail in the coming session. So 1 mole of any gas will be taking up a volume of 22.4 liter. Any gas, if it is taken in a measure of 1 mole, that gas will take up a volume of 22.4 liter provided at STP. STP means at standard temperature and pressure. Avogadro's law can be better understood in a simple way by looking into this example. Here we have 3 balloons. One balloon is containing hydrogen, and in the second balloon we have nitrogen gas, and in the third balloon it's oxygen gas. All these balloons have the same volume. So if these 3 balloons are kept in the same temperature and pressure, what you have to understand? They all contain the same number of molecules. That means all these 3 balloons will be having the same number of molecules if these balloons have same volume and it is kept in the same temperature and pressure. Now let's see Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed his atomic theory. In his theory, Dalton gave the following ideas. Elements are made up of tiny particles called atoms. You know that. All atoms of a given element are identical. For example, if it is an element hydrogen, all hydrogen atom will be same. No change in that. The atoms of a given element are different from those of any other element. Like if it is an oxygen atom, it will be different from hydrogen atom. Atoms of one element can combine with atoms of other elements to form compounds. A given compound always has the same relative numbers and types of atoms. Like hydrogen is one element and oxygen is another element. So the atoms of hydrogen and oxygen can combine together to form water. And it is a new compound. And this given compound, water, should have always the relative numbers of atoms. So water should have 2 hydrogen and 1 oxygen in it always. Otherwise, it is not water. Atoms are indivisible in chemical processes. It cannot be divided. Atoms cannot be divided. That is, atoms are not created or destroyed in a chemical reactions. A chemical reaction simply changes the way the atoms are grouped together. Atoms are never destroyed or made new, but it's during a chemical reaction what is happening actually, it's just getting rearranged. Only its arrangement in the atoms changes when forming a new compound. In that, no atoms are created or no atoms are destroyed. So, Dalton's theory could explain the laws of chemical combination. So this is the end of our session today. Thank you. See you again.